Okay, notes 1, the normal distribution and combining normal random variables. So the first section talks about revisiting the normal distribution. It says a continuous random variable is a variable that can take on any value within a specified domain. Every interval within the domain has a probability associated with it. A continuous random variable with a normal curve is commonly used to describe populations. The area under a normal curve or a given interval represents the probability that a particular x value lies in that interval. Area under a normal curve represents the probability that a particular x value is in that interval. So looking at 3 examples here, if we are saying the probability a randomly selected variable is less than some number x sub a, that is looking at the normal distribution of some x sub a where our value is less than that, to the left. And if we're looking at the probability a randomly selected variable is greater than some number x sub b, then we're going to be looking to the right. Then it says the probability a randomly selected variable is between x sub a and x sub b. Then we're going to be looking at the area between some number x sub a and some number x sub b. It says, remember, x is equal to x sub a. The probability that x is equal to some number x sub a is going to be 0 for any continuous random variable. And that is because we're talking about area here. And if you were just given 1 point, we wouldn't be able to find the area under that 1 point. And also, the probability that x is greater than or equal to some number x sub b is the same as saying the probability of x is greater than x sub b, since individual values in a continuous distribution are insignificant. So since we're talking about a large area, if we were to not include one single point in that area, it's not going to drastically change our answer. So let's look at an example. It says the heights of young women follow a normal distribution with a mean height of 64 inches and a standard deviation of 2.7 inches. If you were to choose one woman at random, what is the probability she is less than 63 inches? So here, when we're solving these, we're using what is called the 4 C's, and that is to communicate, create, calculate, and conclude. Okay. So step 1, to communicate. So it says communicate what your random variable is and the distribution that it follows. So our random variable is x is equal to the height of young woman. Okay. And we know that it follows a normal distribution with mu equal to 64 and sigma equal to 2.7. Okay, the second C, create, says write down your probability statement and convert to a z-score. So we have the probability that our x value is less than 63 inches is the same as saying the probability of z is less than 63 minus 64 over 2.7. That is our formula for z-score. And we get that that probability is z less than negative 0.37. Okay, our third C, which is to calculate, says draw the curve and find your probability using technology. So remember, we're using Desmos, so we can ignore that step there. And what's nice about Desmos, that what we're going to see in just a minute, is that we really didn't need to calculate that z-score like we just did. Okay, so in order to solve this, I'm going to go to Desmos. I'm going to hit on this plus sign. I'm going to go to inference, add probability distribution, and in the normal distribution, I am going to type in our mean and standard deviation. So 64 and 2.7. Oops. Okay, then I'm going to click on this drop down right here, and we want x is less than 63, so that's the left region. And then we type in 63, and we get our answer. Notice we didn't even use the z-score. So for Desmos, okay, if you do a normal distribution with mu and sigma, you can use the x value. Okay. Or you could do mu is equal to 1 and mu is equal to 0 and standard deviation is equal to 1, so the standard normal distribution, and then use your z-score value. So I'll show you that here. Let me go on this next one, and I'm going to add inference, still normal, 0, 1, create distribution, go down here into the left region, and now I'm going to do less than negative 0.37. And then notice how I get the same answer, 0.356, and if I scroll up, 0.356. Okay, so it doesn't matter which one you choose to do, it just matters that you don't mix up the two ways. So that's what's nice about Desmos, is that we don't have to convert things to the z-score if we're given mu and sigma. So here I get p of x less than 63 is equal to 0.356. And it even gives us a nice image of what that diagram is going to look like, but we don't need to draw that diagram in order to get the points for our answer. And then the last step here is to write our sentence. So it says the probability a randomly selected woman is less than 63 inches tall is about 35.6%. Okay, the next example says the heights of young women follow a normal distribution with a mean height of 64 and a standard deviation of 2.7. Okay, so those numbers have not changed. If you were to choose one woman at random, what is the probability that she is greater than 66 inches tall? So we would go through all these same steps, but since we're looking at the same steps as the problem above, the main thing that's changing is my probability. So this is the probability that x is greater than 66. Well, I can go over to my normal distribution here that I did for the last one, change it to the right region, and then change this number to 66. And I get my area, which is 0.229, which means the probability a randomly selected women is greater than 66 inches tall is about 22.9%. Okay, the next example says if you were to choose one woman at random, what is the probability she is between 64.5 inches and 70 inches tall? Well, again, everything is the same but my probability statement. Get Desmos back up here. Okay, so that means I have the probability, oops, sorry, I had the wrong thing picked. Let me scroll down. Where were we? Right here. So this is the probability, and my pen is not working. Okay, here we go. Let's try this again. Okay, the probability of 64.5 0.5 is less than x less than 70. I would go over here and hit enter. Change this to 64.5 and then change this one to 70. And I get that this is equal to 0.4135. And see, I can even drop down that arrow to show more decimal places here. So actually it's 4134, not 45. Let me change that. Okay. Which means I have the sentence that the probability a randomly selected woman is between 64.5 and 70 inches tall is about 41.3%. Okay, so then we're going to talk about combining random variables. Combining normal random variables. So notice we're still talking about shape, center, and spread, just like when we were talking about the normal distribution. So it says combining two or more normal distributions will result in a combined normal distribution. Okay, so the distribution does not change. Okay, the center, if you have the expected value of x plus y or the expected value of x minus y, that is going to be the expected value of x plus the expected value of y, or the expected value of x minus the expected value of y. Remember, E of x can also be written as mu of x. They both are going to be the same way to represent the mean. And then spread for standard deviation, remember, no matter if we are going to add or subtract, we are always going to add the variances together. So this is the square root of sigma x squared plus sigma y squared, which is going to be the same formula here. Random variables must be independent in order to use that standard deviation formula. So it says, why are we combining? We combine multiple normal random variables to make a new distribution. So let's look at an example. It says in a 4x100 track relay, 4 team members each run 100 yards, and their combined total time is their finishing time. Suppose the times taken by each runner to complete their respective legs of the relay are independent of each other and follow a normal distribution with the following parameters. So for each runner, it gives us the mean and standard deviation. It says, what is the probability that the total time taken by the team to complete the relay race is between 42 and 46 seconds? So we follow our 4 C's. So we're going to say our random variable t is going to represent the total time. And we are trying to find the probability that the total time is between 42 and 46 seconds. Okay, well, let's represent this random variable t to represent the total time of all the runners. So runner 1 plus runner 2 plus runner 3 plus runner 4, which means the expected value for the total time is going to be adding all the means together for each of the runners. So that's 12 plus 11 plus 10.5 plus 11.5. And then standard deviation of t is going to be taking the square root of each of the standard deviations squared and adding them together. So 1 squared plus 0.8 squared plus 1.2 squared plus 1 squared. Okay, and if we were to add these together for expected time, we get 45, and for standard deviation, we get 2.02. So instead of going through these and calculating the normal distribution for each runner separately, we are now calculating the normal distribution for the total time of runners. So we have t follows a normal distribution where mu is equal to 45 and standard deviation is equal to 2.02. So I'm going to go over here and I'm going to change that. Okay, notice I don't have to go and add a new normal distribution. I just need to change these numbers. So 45, comma 2.02. Okay, and then in order to find that probability, I'm going to go to enter and I'm going to change my numbers to 42 and then 46. And I get that the probability of total time between 42 and 46 is equal to 0.621. So if I was to write that in a sentence, I would say the probability that the team finishes between 42 and I'm going to continue down here, 46 seconds is about 62.1%. So that's a very high probability. Okay, and then the last topic here is talking about subtracting normal random variables. Okay, so we're looking at that example. And then I'm sorry I went into here, so not to confuse anybody, I am going to change my color. So it says you are managing a manufacturing process that involves 2 sequential steps taken at the same time. The 2 processes work independent of each other, and the time taken to run each step can be modeled with a normal random variable representing the processing time. Process 1 has a mean and standard deviation. Process 2, mean and standard deviation. It says you need the difference in processing time to be less than 10 minutes for a critical operation. What is the probability that you meet this requirement? So we are given the information for process 1. Let's label that x. And we know x follows a normal distribution where mu is equal to 25 and sigma is equal to 5. So I'm just pulling the information from the problem. So we have process 2, and let's call that y, follows a normal distribution of mu equal to 20 and standard deviation equal to 4. We are trying to find the probability that x minus y, because it talks about the difference, is less than 10. Well, in order to find each of these, we have to subtract the 2 means, and then we have to use the formula for standard deviation to find the new one. So mu of x minus y is going to be 25 minus 20, which is 5. And standard deviation of x minus y is going to be the square root of 5 squared plus 4 squared, which gives us 6.403. So this leads us to our new distribution, which is x minus y, that follows the normal distribution of mu equal to 5 and standard deviation equal to 6.403. And since we're trying to find the probability that x minus y is less than 10, I'm going to go over here and I'm going to change my normal distribution to have the correct numbers, so 5 and 6.403, and I'm going to do less than, so that's going to be the left region, 10. and this gives me 0.783. So my sentence here would be the probability that our processing time will be less than 10 minutes is about 78.3%, which is a very good probability.